Okay, how's that look? I haven't looked up yet. Yeah, okay. There's a rule. Did it get quiet all of a sudden, or is it good? Can you guys still hear me? Okay. Every time somebody here says AI, you have to take a drink. So anyway, thanks for coming to the AI users group thing. We're going to talk about AI. Very excited about AI. Not a bunch of rule followers. I've seen a couple of drinks. That's okay. All right. So again, this is probably going to be like middle of the road. It's not going to be super advanced. It's not going to be like condescendingly simple. It'll be somewhere in the middle. But I like to talk about things that I think are important in the AI world. If you saw my last talk, I talked about how AI models are unhinged. I talked about sycophancy, persuasiveness, situational awareness. And lo and behold, those are topics that are being talked about, thankfully, a lot more often. But today I'm going to be talking about the future of AI data and the challenges and solutions in the era of exponential growth. So, I mean, I think all the time we hear like, God, these models, they're getting so much more capable. And they're getting that capable because the data, all I got to do is scale them up. Okay, well, I mean, I'm not sure I actually believe that, but regardless, scale is how we've gotten where we are today. And I don't know if did anybody here see the clip of Kevin Scott, the CTO of Microsoft, talking about the compute clusters that they use to train GPT-3 and 4? Anybody here? No? Okay, good. Well, okay, you, Julian, good, my guy. He was saying, okay, look, if you look at this here, I know you can't really tell, but this is a shark. He's like, this is what the compute cluster size was for GPT-3. Think of a shark, great white. GPT-4 and Orca, which is actually related to the dolphin family. And then the next compute cluster that they're spinning up right now, you should think of a blue whale. So, and that is orders of magnitude larger than the great white that was used to train GPT-3, than the Orca that was used to train GPT-4. It is gigantic. It's huge. And the scale is incredible. So rapid progress in AI is driven by scaling of models through compute. And actually, this is a semi-analysis, and they did a nice kind of scatter plot here to show, around 2020, we started building out some models. GPT-3 was here. Here's the floating point operations. So, you see the scatter shot. You see a couple of labels here because, these are recognizable models, but you see the compute over time for the x-axis and the y-axis getting larger and larger, right? Getting pretty big. The Llama 3, 405 billion parameter, I'm hyped for that. I think it's going to be incredible. But that is all to say that these models are getting big, very big, bigger and bigger, way bigger than what we have currently. And so the exponential growth of AI compute it's exciting. I mean, when I try and visualize what a stack of H100s or H200s or I don't know, I5, whatever the fuck they're going to call them next, and the data centers that are going to support all of that compute, it's incredible, except that all of that compute is going to be starved for data. So you can have all the compute in the world, but if it ain't got none to compute, then I think we're potentially reaching a point where we'll run out of data. So there are limits to LLM scaling based on human-generated data. This isn't something where we're going to match pace with the compute that's out there. I mean, NVIDIA is going wild. Google has more compute than the next 4 competitors combined with their TPU clusters, and the compute that's going to be used to train the next models has been growing 4 to 5 times from 2010 to 2024. It's big, 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 big. We're thinking like Moore's law type of, scaling laws happening here. And Kevin Scott, is a pretty cool dude. Look at that goatee. He was saying, like, buckle up because it's going to get wild. This is GPT-4, but this is GPT-5. When? GPT-5 when? Maybe a year and a half, who knows? But it's big, right? Would you agree? Does that look incredibly large? It's kind of a big deal. Okay, Kevin Scott and the Microsoft gang, they're all talking that this is going to be a big deal. The problem, though, and I promise this is the first and last AI generated image. It's going to be part of my fucking presentation because I'm already sick of them. No offense to everyone who's using them literally every single day in all of our slide decks, but I'm trying to not do that. There is a looming data crisis, people. Okay, and once again, there are emergency exits back here. Emergency exits back here. If you guys freak out thinking about this, remember where your exits are. So there is a looming crisis. I don't want to use, too much rhetorical language, but it's actually happening right now. Does anybody, show of hands, does anybody know who this is? Okay, we got a couple of people here that know. Other than that, this is Johnny Five from Short Circuit. It's a great movie from the 80s. Actually, I don't think it ages very well. It's a little bit problematic, but back in the day, it was great. And it was this robot who was part of like a military killer robot battalion, I guess. And he was like, butterfly, wait, I don't want to kill him. Like, Johnny Five, I'm cool. I need more input. So he broke free and he would like find a library and like flip through all the books. And he was like, as he learned, man, he got like smarter and kinder, which is probably the way that, language models are going to go. The more they learn, the more powerful they get. They're going to be kinder and kinder. But this is him being pissed off because of the looming data crisis. And, I can't blame him because data is the new bottleneck, I would argue. Data is a big concern for all the frontier model developers right now. I don't think they really communicate that publicly, but it's a problem. And so I'm going to touch on this paper to start with. The title, Will We Run Out of Data? Limits of LLM Scaling Based on Human-Generated Data. So this paper looks at some, does it follow me? I didn't do it that time. It looks at some predictions regarding how much net new human data we can count on before running out completely. So in the abstract, they forecast that the growing demand for training data based on current trends and estimate of total stock of public human text data, our findings indicate that if current LLM development trends continue, models will be trained on data sets roughly equal in size to the available stock of public human text between 2026 and 2032. So by 2026 at the earliest, which is like, it's like a year and not even a year and a half. At 2032 at the longest, but like they're saying within an 8-year span, no more human data to train on. And the scaling laws, they bear this out. So the demand for public human text data is likely to continue growing. And in order to scale the size of models and training runs efficiently, large language models, LLMs, are typically trained according to neural scaling laws. So we need this text data. Now, you keep hearing me say human text data, and that's going to be important in a minute. But here's a graph from the paper, and essentially what they say is like, look, basically here or here, not really sure, This actually lines up with the human population and the stock of data. This kind of ever increasing trend will level out and will be at our end of having viable human data between 2026, 2027, 2028, 2029. I mean, point is that it's not keeping pace with the hunger of these GPUs and TPUs and these compute clusters to get more and more data to train more and more performant models. Just not happening. So when we look at this trend here, again, this is the human population. This trend is pretty consistent. And then we have internet users. And the trend has kind of gone up as the internet has proliferated, and then it's going to trend back down. And I think this assumes that content that's generated by human beings stays relatively consistent. There's an indexed web, so that's the data that Google knows about. There's more data out there than what Google knows about, but they're a pretty good measure. And then the internet population. So this is the amount of text created by people online, non-AI generated text. And they model this by looking at how many people use the internet and assuming each person creates a similar amount of text over time. So again, this is not keeping pace with the hungry GPUs and TPUs that we use to train them. So why not use synthetic data for training? Right? I told you I was going to talk about this. Why human generated? Now, I don't want you to answer now, but does anybody here have an idea why? You just raise your hand. Why has it got to be human generated? Anybody know? This is my guy right in the back. And see, afterwards, us partying. Okay, why can't you use synthetic data? Well, because of a thing called model collapse. So even though I'm talking about text, this is a nice sort of graphical representation of Jan LeCun's original convolutional neural network, which is recognizing numbers, right? And this is an example of, over time, training on synthetically generated data, and it loses all of its resolution. But the abstract from this paper says, what will happen if GPT-N, whatever generative pre-trained transformer, once LLMs contribute much of the language found online, we find the use of model-generated content and training causes irreversible defects in the resulting models where tails of the original content distribution disappear. We refer to this effect as model collapse. They originally were going to call it model Alzheimer's, but it was offensive, so they didn't do that. And they demonstrate that it has to be taken seriously if we're to sustain the benefits of training from large-scale data scraped from the web. Indeed, the value of data collected about genuine human interactions with systems will be increasingly valuable in the presence of content generated by LLMs and data crawled from the internet. How many people are hearing about model collapse for the first time here? And be honest. Okay, quite a few. Most everyone, right? Okay, so the curse of recursion, it's called. It's not a scary sounding thing. The curse of recursion. Yeah, and it basically talks at length about how training a model on its own outputs causes it, after just a generation or so, to start to become gibberish gobbledygook. So in this example, we have the input, and then we're training on this input, and then we're looking at the output in generation 0. And essentially, it's talking about an architectural style, perpendicular architecture in 1360, okay? And that's not really important, but what's important here is as it's trained on these same outputs, you can see it just becomes nonsense. So some started before 1360. We typically accomplished a master mason and a small team of itinerant masons supplemented by local parish laborers, including the Poinswright, but other authors reject this model, blah, blah, blah. Okay, very architecture, like, stands architecture, right? And AI, talking your language. But then by the last generation, architecture, in addition to being home to some of the world's largest populations of black-tailed jackrabbits, white-tailed jackrabbits, blue-tailed jackrabbits, red-tailed jackrabbits, yellow. Actually, I kind of love the one before. It's like talking about this guy. Where is he? Poins, right? Architecture in England, in an interview with the New York Times, Wright said, I don't think there's anything wrong with me being able to do what I want to do. This doesn't work for me, he added. I don't know if you can call it funny. Like, this doesn't make any sense, right? This is what happens. Okay, so you can't, everyone's like, AI is just gonna like turn itself. And that's makes a lot of sense. It just turns out it causes model collapse. And in fact, if we look at perplexity in a graph, this one's not as cool. This one is generation 0. Look at that beautiful blue arc. Okay, and then the next generation is like nice, right? And then after a while, it's just like garbage. It's just because later generations start producing samples that would never be produced by the original model. They start misperceiving reality based on errors introduced by their ancestors, which honestly, same. My ancestors are, they caused a lot of problems for me too. So anyway, but wait. Is model collapse really a problem? I mean, it might not be. Actually, there's a paper. It says, is model collapse inevitable? So we're breaking the curse of recursion by accumulating data and synthetic data. And in this paper, they say, okay, look, recent investigations into model data feedback loops propose that these loops cause model collapse, essentially. But what if you don't replace old data? Okay, and instead you accumulate synthetic data in conjunction with original human data. Organic, I like to call it. So, they confirm that replacing the original data by each generation synthetic data does indeed trend towards model collapse. However, they demonstrate that the accumulating of successive generations of synthetic data does this. So here is original data replaced by synthetic data. Next generation replaced by synthetic data. And you see this collapse happening. But original data, synthetic data, original data, synthetic, original, it's straight, it's trending straight. So, I mean, that's good news, right? No, I mean, it doesn't address the problem. It says, oh, here's a way that we could continue to train models and use synthetic data. I mean, as long as you're sitting on, petabytes of original human data, if you want to train a model from scratch, this doesn't solve that. So I'm going to say training on synthetic data is still a problem. It really is. Which is why human-generated data is so important. So what now? By the way, I want to go back. My daughter was like, why don't you create an animation on the so what now? So Zoe, it worked. That killed. Thank you, babe. But wait, who's heard of AlphaGeometry? Oh my God, thank God nobody has except for Rafiq, who's a speaker. He should. I already know about it. Okay, here's a case study in synthetic data. This is really interesting. So DeepMind, okay, they've created a model that was designed to solve geometry. Geometry is incredibly difficult to solve using AI. Why? Because it's all drawings and graphs and shit. Like you can't just like write about that. It's inherently a visual as well as a mathematical and textual type of exercise. And DeepMind created AlphaGeometry. And forgive me if I read directly from the abstracts and things, but I mean, like, let's keep it scholarly, guys. Current machine learning approaches are not applicable to most mathematical domains, owing to the high cost of translating human proofs into machine verifiable formats. The problem is even worse for geometry because of the unique translation challenges, resulting in the severe scarcity of training data. They propose AlphaGeometry, a theorem prover for Euclidean plane geometry that sidesteps the need for human demonstrations by synthesizing millions of theorems and proofs across different levels of complexity. So AlphaGeometry is a neurosymbolic system that uses a neural language model trained from scratch on their large-scale synthetic data. And it's amazing. What they basically did was said, okay, we're going to tell the model to generate hundreds of millions of polygons and proofs alongside them. So the model, they did that. And they said, okay, now train on all of that you just did. Train on the polygons that you created, train on the proofs that you created. And lo and behold, AlphaGeometry this is a previous state of art, which is a 10 out of 30 questions. AlphaGeometry was 25.0, a gold medalist, 25.9. Now, okay, these are high school mathematicians, but these are high school mathematicians. I mean, they're fucking geniuses. How many here were high school mathematicians? The whole back row, guys, was. So it's a big deal, right? And then, so that's a little bit of good news. I'm gonna get it back a little bit here. Okay, that's some good news. Synthetic data has done something good. In fact, DeepMind does all kinds of really incredible, groundbreaking research, and that is just one of the many things that they've done. I'm really impressed by them. And so I would always encourage everyone here to check out their papers. They've got brilliant stuff going on there, including AlphaGeometry. But we're talking all about text, right? And language models that are just text, it's kind of like so last week, which in AI world is like so last year. Multimodal, the multimodal revolution. I mean, this is what I'm talking about. I mean, if you're like in the know in AI, if you're interested at all in AI, I mean, if you like put some respect on its name, you're thinking about multimodality. I mean, that's the thing. What's a modality? So a modality would be text. Another modality would be images. Another modality would be video. Another modality would be audio. There's even some other crazy modalities I'm going to talk about in a minute that nobody's even ever heard of. Maybe you have, but some crazy ones. Here's a great example, Gemini. Gemini is a fundamentally multimodal model. So they trained it jointly across image, audio, video, and text. Okay, that's very important. You probably have heard of, who's heard of GPT-4o here? I just think a couple of you guys who, wake up. Everyone's heard of it. Come on. You have. Maybe you haven't. That's, the O stands for Omni, which is like multiple kinds of modalities. But in multimodal AI, what we're talking about is the text, audio, images, video, all being fed into a tokenized and fed into a transformer. And then you have an image decoder, a text decoder, like you have your outputs, multimodal inputs, multimodal outputs. I'm going to feed it a video or feed it some audio or feed it an image and ask it about the thing, or, write and say, tell me about this thing, and it's going to give me an output. That's what all the like real next level models are doing. They're multimodal. Who else is doing interesting stuff in this domain? Meta is incredible. Jan LeCun, God. These guys are doing amazing research. They've open sourced their models. And ImageBind is an amazing paper and an amazing research project. Hey, How are you? It's good to see you. It's an amazing paper. And what they did was they demonstrated that, look, you can actually train a multimodal model on pairs of modalities, pairing it with an image. So what type of data? So we're talking about, let's see. Okay, so let me say, okay. They present ImageBind, an approach to learn a joint embedding across 6 different modalities: images, text, audio, depth, thermal, and IMU, inertial measurement units. It's just like data about inertia. They show that all combinations of paired data are not necessary to train a joint embedding, and only image paired data is sufficient to bind the modalities together. I mean, this is big-brained, very innovative research, and we're not tied to simply relying on petabytes, 100 libraries of Congress worth of text data. Other organizations, I mean, not really OpenAI, they don't really release much interesting research at all, so I don't think about them very often. They suck. They're bad for the world of AI, and that's my own personal, they suck. But Meta, this is a big deal. This is actually helping to move things forward and to train multimodal models using different types of modalities, and you don't have to train on all these different modalities. You can just train on whatever modality along with an image. So pair those along. It's an incredible breakthrough. So here you have image video, and just kind of representing how with just image video training, it's able to now transfer learn these other modalities: IMU, audio, text, depth, heat map. Pretty good stuff. Next, embodied AI. Anybody know what embodied AI is? Raise your hand. Okay. Putting it into a robot. This is Paul Me. This is my guy or gal, or actually, let's not genderize it. This is my thing. This robot. I love Paul Me. Paul Me has done some really interesting things. Here's a long horizon task. It was said, hey, go to the kitchen, find the rice chips, bring the rice chips back to me. So it had to plan. It had to go, okay, go. I have to go to kitchen, okay, kitchen. Find, I have to find. Chips. What kind of chips? Rice chips. And then bring them back. Okay, so it's able to do those things. And it's a groundbreaking example of pushing AI models beyond text by incorporating diverse sensory inputs, particularly for embodied tasks like robotics, taking in all kinds of different sensory data. It introduces a concept of embodied language models where language understanding is directly integrated with real-world sensory experiences. So it's now not just like taking in text and going like, oh, I definitely understand now because I read about it. We're seeing over and over in the world of AI that just text doesn't really give real understanding, real concept of the world, real reasoning. So it talks a lot, though, about how you need different modalities, and you need a model trained on its own senses to be able to build a sense of how it can maneuver in the world, how it can actually solve tasks, do long horizon planning, which is like long-term planning. And that multimodality has to be there for it to be grounded. What's grounding? Well, if you don't have grounding, you got no world model, no planning. Boom, 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 boom. No world model, no planning. Okay. Grounding and the signal grounding problem was best described by John Searle, the philosopher, who said, look, here's a scenario, here's a thought experiment. You see this shape, followed by this shape, followed by this shape. I put you in a room and say, once you see those, you produce this shape, followed by this shape. It's called the Chinese room experiment. And essentially, the idea is you have a couple of people, they write a question in Chinese, they put it in the room. This guy inside's like, well, I got these instructions. When I see the symbol, I match it with this other symbol, I spit it out. And the outside, gosh, whoever or whatever is in that room is an intelligent Chinese speaker. Well, Searle said, that's actually what computers are doing. That's what AI is doing. It's not understanding. It's taking in images like symbols, not even understanding what they mean. Looking at the symbols going, oh, symbol A corresponds to symbol X. I know to spit out symbol X. And lo and behold, the outside of the room, people go, very smart. It understood. It knows Chinese so well. It's such a good Chinese speaker. But what's the path forward there? So ultimately, we're moving towards multimodality, and we're moving towards embodied AI, AI that can live in the world. And path forward is, it looks a lot like this Dr. Eureka research that came out from NVIDIA, where they're training one of those little dog robots to perch on top of a yoga ball in a 3D model environment, not in the real world. They trained it, don't look at this. They trained it in a 3D world, not in the real world, synthetic environment. And then it was able to recreate the Abbey Road cover. I mean, like, do all of these things in all of these different environments by balancing on this ball. It wasn't trained in real life to do this. It was only trained in a sim. We call this sim to real. And so here it is also manipulating objects. It did like many different simulations of moving a square cube or a cube around in its hand, and then was able to zero shot in the real world, manipulate that cube. So that's my talk. Basically, don't sleep on the fact that we need human-generated data for text. And also, don't forget that multimodality is absolutely the future. There are solutions for training because of multimodality that don't rely squarely on human-generated text. And that beyond that, giving robots senses so that they can ground their understanding of the world in sensory experiences is a next level, is a step function change in AI. And that we actually may be able to use all that compute that we've got to generate hyper-realistic synthetic worlds and further train these embodied AI to navigate in the world. I am the principal consultant and founder of Long Horizon AI. If you would like to snap my QR code, you can. I believe these slides are going to be available afterwards as well. But I thank you all so much for coming.
Thank you, Lee. We're going to take a few questions.
I didn't think there was going to be questions. I don't know if I could do that. I'm just kidding.
Does anyone have any pressing questions?
My guy in the back, he is my guy.
Start in the back.
Max.
Yeah, good memory.
Wie geht's?
Thank you. Good, danke. Thank you for the presentation. Super entertaining, really well done. I learned a lot. Amazing.
Thank you.
I have one question. I feel like maybe there's a bit of like an underlying hypothesis that the only way to advance existing models in a meaningful way is like shoving more data down their throat. And I'm not sure if I would fully agree with that. I'm pretty sure if you take like exabytes of training data and put it through GPT 2.0, it would still be a crappy model at the end of the day, right? So what would you say to somebody like me who says like maybe the true improvements from of models is not by just generating or feeding more data into that, but actually improving the underlying models that are able to get the right conclusions out of the existing data. That being, you know, just as a finishing note, as an example, I believe if you read all the books in the world as a human, right, and like read all the data, you would probably be smart and intelligent enough to answer all the questions that you would have to generative AI. So why wouldn't that work with a great algorithm?
Yeah, I mean, I think so. That's a great question. First of all, I think if you asked Ilya Sutskever or any of the people at OpenAI, they would say, oh, no, data is how you make these models better. We just threw more data at it and it got smarter. And I tend to think that what we're seeing is not the AI being smarter necessarily, is the AI being overfit on data. Overfit meaning that it's trained on tasks already and it remembers them when you ask them about it. That's why models are failing at the RKGI challenge, which is like a novel type of like, solve this really simple puzzle. And LLMs really can't do it, not in any meaningful way. Secondly, I would say there's a great, I think it was by EBREX, Scale AI, where they looked at the GSM-8K, which is grade school math, 8,000 questions, and they looked at the premise was actually models are overfit on this benchmark data. So let's create a GSM 1K and create 1,000 new novel math questions, and let's rerun the benchmarks across all these models. And you'll see that the Mistral, their best performant model was like it couldn't solve a thing because now these were novel questions, right? So people were like, oh, I got this really small model to be really smart. I don't know about that. I really think that actually what we're looking at there is overfitting in these models and that the architecture is not moved forward much. All of the big breakthroughs that I've seen have been with models that are incorporating other kinds of architectures as well, like function search and different types of architectures in conjunction with language models. And I think that if you ask anybody in the space right now, they would argue that scale has made a big difference. Another caveat there, though, is like the number one paper at the NeurIPS was how emergent behavior is a mirage, where essentially it said, look, emergent behaviors don't really happen the way that you think that they do in these models. What really is happening is a measurement problem where a model is deemed to have an emergent capability when it gets a correct answer on the problems that we're feeding it. But what really is happening is that actually the models are progressively and smoothly getting better and better at those answers as data is thrown at them. So I don't know, maybe it's a long and rambling answer, but I would argue that the big model producers that are producing foundational models out there would say, no, data and size is how we're getting these more performant models. Thanks, Max. Great question. Anybody else? Yes, can you bring her the mic?
It's so nice to see you again.
You too.
In person. I just want to ask like one question. I'm not too deep into the research. I just recently graduated and I'm a transport engineer. Yep. Yeah. So my question is, given that we have that multimodality aspect of AI, in future it's only going to get better. So how can we address security risks? Given that I know you don't like talking about OpenAI, but Sora model has like there was a video that went really viral where two puppies were playing in the snow. So it's cute, but also it's very scary that it's so close to reality. Yeah. So how can we address security risks in future, given that there's deep fake, there are a lot of things which are being addressed, yeah, like which is very close to reality, and it's also scary.
Yeah, but I mean, I think first of all, when it comes to security at OpenAI, they're leaking like a sieve, security people, because they actually aren't concerned with AI alignment, AI safety. That's why all of their top AI super alignment team has resigned. A lot of their security alignment team has resigned. They have really not proceeded carefully. I would argue that the voice demo, the big Scarlett Johansson kerfuffle that happened, was a very problematic event, not because it sounded like her. I don't care. It sounded like her because it was a very flirty and manipulative model. And if you guys, I don't know if anyone has access to the slides from before, but I talked about manipulation in models. I mean, that's a big problem. Security, I think we've really messed up on that side of things. I think it's hard for me to think about how we're going to get the genie back in the bottle when it comes to making these models safe now. There's been such a race condition that's happened because of OpenAI. Basically they yeet ChatGPT into the world, and everyone's just like, oh, now I got to catch up. I'm concerned about that. Luckily, no world model, no planning. So I think we're okay for now, but man, we need really safety-focused researchers out there pushing for the most responsible deployment of AI. Shout out to Anthropic and Google, actually, for all their fuck-ups and how they've deployed some of this stuff. They have very good safety principles in place and have for a long time, so I hope that kind of thing catches on. Yeah, I think I'll probably take up enough time, but yeah.
Once again for Lee.
Thank you.
Thanks so much.
Yeah, my pleasure.